Hi everyone, this is Jay, your instructor for Computer Networks, and in this session we are going to discuss the control access protocol. If you remember, the multiple access protocol has three types: the random access protocol, channelization, and the control access protocol. We have discussed the random access protocol as well as the channelization. In today's session, we are going to discuss the control access protocol. Now, what is this control access protocol and why it is needed? In the multiple access protocol, the protocol was implemented in the shared channel. Shared channel means that the channel it is used by more than two devices. And when the channel is used by more than two devices, there are highly chances that there will be some collision in the network, because if two or more devices starts to send data at the same time, that data will be collided, and when those data will be collided, the signal level will be changed drastically. And when the signal level is changed drastically, when receiver receives data, it will not understand that data because the signals are now abnormal. So that is why we need some mechanism, we need some protocol, and the control access protocol is needed. So in the control access protocol, the station consults one another to find which station has the right to send. So all the stations cannot send data at any time. They will send data at particular amount of time, and when they are having some particular privileges or some permissions. If they are not having any permissions, in that case they cannot send data, they can only receiving data. They will be receiving data. So it cannot send data if it is not authorized by all the remaining stations. And the types of the control access protocol: the reservation, polling, and the token passing. Let's see the first type, which is the reservation access. In the reservation access protocol, there is mainly two types. The first time is known as the reservation period, and the second time is known as the data transmission period. So the total time is divided into two parts: the reservation period, and the second one is known as the data transmission period. For example, there are 5 stations that need to send data, that wants to send data. So if any station want to send data, in that case they have to do reservation before sending any data. For example, the length of the reservation period is 5 seconds, and there are, for example, 5 devices. So each device will be having particular reservation slot of 1 second. So in that respective 1 second, they have to announce that whether they have to send data or not. For example, there are 5 devices: 1, 2, 3, 4, and 5. So suppose station 1 want to send data. So in the first second, which is the reservation slot that is allocated for device 1, in that first second, device 1 will announce whether it wants to send data or not. And it can announce by sending 1 or 0. So if it wants to send data, it will send 1 in its respective reservation slot, and in that respective reservation slot, if sender is sending 1, all the devices, when they will receive 1, they will understand that okay, the first message will be sent by the device 1. After the reservation slot of device 1 is completed, the next 1 second is for the device 2. Again, device 2 has to make announcement that whether it wants to send data or not. If it wants to send data, it will send 1 in its respective reservation slot. If it does not want to send in data, it will send 0. So when all the station receives 0, they will understand that okay, device 2 does not want to send any data, and they will understand that the device 2 has skipped the transmission. So this is how the reservation access works. So you can see that the first 5 slots are the reservation slot. You can see that in the slot of the device 1, it has send 0. So when 0 is received by all the devices will understand that 1 is not sending any data. After some time, 2 has sent 1 in its reservation slot. So when 2 has sent 1, it means it has announced that I will send the data. So all the station will understand that the first data will be the device A. It will be by the device A. After 3 has announced 1, so it has made reservation that after device 2 I will send data. 4 has sent 0 and 5 has sent 1. So you can see that in the reservation duration, in the reservation time, 2, 3 and 5 will be sent data. So they have announced, they have made the reservation, and 1 and 4 has skipped. So they will not send any data, and they are not allowed to send any data. So they will wait. So after the reservation slot is completed, the next slot is known as the data transmission slot. In the data transmission slot, the device 2 will send the first data, after that 3, 4. After the next reservation slot will be there, and again the data will be sent. So this is how the reservation access works. The second type is known as the polling method. So how the polling method works? In the polling method, all the devices that wants to send data, all the device cannot send data because all the devices are divided into two categories, the master and slave. So all the communication will be initiated by master, and it will be sent and received via the master. So it is exactly like the faculty that is taking lecture in your classroom. So if it is something like, if faculty is asking question to the particular student, that particular student, he has to answer the question, and other student has to remain silent. And faculty is asking another student, then he has to answer the question, and other student will remain silent. So in your classroom, the faculty can be considered as a master, and the students can be considered as slave, which is not true in the all cases, right? So all the communications are initiated by the master. So you can see that this is the poll which is sent by sender to receiver, and if receiver wants to send any data, it will provide the data. And if sender send data, it will ask. If receiver wants to reply, it will send with the data. So for example, if sender is asking some device that whether it wants to send any data or not, if that device has any data, it will reply with the data. If device does not have any data, it will reply with the negative acknowledgement. So from that, the sender will understand that the receiver does not have any data to send. The next type is known as a token passing. So what is the token? Token is a fixed pattern which is which is known by all the devices. For example, the pattern of the token is 1, 1, 1 and 1, 4-bit. So if any device receives these 4 ones, they will understand that the token is received. And in the token passing method, device can send data only if they are having token. So you can see that the first device has token. So when it has completed the transmission, it will pass the token. You can see that the token is passed to the next device, and if that device has nothing to send, so token will be passed to the next device. If that device has data to send, so it will send the data. So this is how the token passing works. The flow of the data, the flow of the token can be clockwise or anti-clockwise depending on the admin or the users that want which way the communication should be happen. So there is a major flow in the token passing, is that what happen if the token is lost or token is corrupted. Because all the devices have understood that the value of the token is 4 times 1, right? But if due to the noise in the channel, if the value of the token is changed, So if the value of the token is changed, in that case the devices will not be able to understand whether the received data is token or actually data. For example, one bit is changed and token value has become 111 to 1100. So when 1100 is received by a device, it will understand that okay, there is some data which is sent by other devices, so it will wait for the token. But the device that has completed its transmission has passed the token, and the received has, because receiver has received the corrupted token, it will continuously wait for the token, and the communication will be in the deadlock situation and no device will be able to communicate. So this is how the token passing works. And this is it for today's session. Thank you so much.